was not uploaded in the app. There is a shift in app which we are making. I think some people would have faced this problem. Those who are aware about the app and minding about the app, they will be aware that we are making a change in the app. What is that? We are making the online students, offline students to be properly separated, and that's why some issues were there. Ma'am assigned it long back, but since the app was changed, it did not reflect to you. But I can tell what was the worksheet given. Worksheet was the Sunday's test of the first week. So you are supposed to finish that and send. So since I have told it now in the class, I'll expect everybody of you who is there in online, everybody of you who are attending the classes online, to once again rewrite your test, not as a test, as a worksheet, and send that to me over the WhatsApp. Don't send. I'll create a link in the app once again for you, and there only you should upload it. Again, I am repeating for all the students who are attending online, worksheets are updated time to time, and you are supposed to upload your answers in the app only. Don't send it through WhatsApp to other people. It's my request to you. Mithun, shall I put you in waiting room? If you are not listening to me, I'll wait for 2 more minutes. One second, Kirti. Yes, Mithun, what you are saying? This issue in camera should be rectified, man. How? This is not permitted actually. Make some arrangement for that. Yes, Kirti, what you are saying? Please, go ahead. Yeah, that's what. The change in app is creating the problem. The marks visibility has gone. I will just once again verify and I will make everything correct by this week. Okay? Even the previous marks visibility would have gone because of the shift in the app. Yeah, because the app has been shifted. So some people will have some trouble in that. We are retrieving all the previous data and soon it will be visible to you. Okay? Fine. So if I remember in the previous class, we have learned the magnetism and matter chapter, and today we are supposed to start chapter number 6. Believe me, we have entered the interesting part of physics now. I believe right from the 4th chapter itself. If you are there in the 4th chapter regularly, the physics becomes interesting. 1 and 2 is little vague and raw. If you are attending properly, it is also interesting. If you ask me, it is interesting. But from my experience of teaching, I am saying 1 to 3 is the trouble creating chapters. 4th is lengthy but interesting. I always like that magnetic field finding. V naught I by 2 pi r, V naught I by 2 r, V naught I square by 2 into a square plus r square power 3 by 2, F is equal to ILB sin theta, F is equal to QEB sin theta, tau is equal to NIBA sin theta. I like all these things. If you ask me, I will say 4th chapter is very, very interesting. Then comes 5th chapter, theoretical chapter, but again if you understand diamagnetism, paramagnetism, ferromagnetism deeply, it's interesting. And after this, which is EMI, AC, EMW, are going to be 3 simple interesting topics in physics. Once again ray optics will come, which will be easy but once again lengthy, and after that following up everything is going to be simple. So physics has become simple now if you are attending the classes properly. If not, then please check yourself where you are going wrong. So we are entering today in one chapter which is very scoring chapter, believe me. Not only in school examination, even in competitive examination. Questions will not be twisted much from this topic. And whatever comes in the NEET and JEE also, you can attempt it easily if you are knowing the basics of EMI. Same follows with AC also. AC looks complex. Some of you would have learned in school by now AC. It looks complex, but actually it is very simple. L circuit, C circuit, R circuit, LCR circuit, resonance condition, acceptor circuit, power factor. It's very interesting, simple also. Very simple. There is a definite set of instructions. We follow that, you will be able to understand it very easily. So today I will try to finish as much as I can finish in EMI small chapter, and then I will go to AC. I will finish AC also in the next class. So probably now EMI AC will not take much time. By the time this month ends, we will be done with volume 1, hopefully, if everything goes fine. Sit man, nothing else speak. Where you are taking your chair? Inside the room you are taking. Sit there itself, man. Yeah, sit there. So let us not waste time further in speaking. Give the heading as EMI, Electromagnetic Induction. Those who are coming regularly, they may remember that I have covered some topic of this chapter already while teaching chapter number 5, which is Lenz law. I'll repeat once again, don't problem in that. But that was some complex part of this chapter, which is definitely going to come in the board examination. Lenz law. Okay. Let us start this chapter now. So, pay attention for 2 minutes. I'll give time for writing. Those who have joined now, that is Harvish, Anshul, please on your videos here. Joining late without video. Okay, coming back. So, in the 4th chapter, before I taught to you Biot-Savart law, I gave some introduction where I told you there was a very famous scientist, Hans Christian Ørsted. He was the one who discovered the magnetic effect of electric current. Whenever current flows through a conductor, a magnetic field is produced around it. Who found this? It was found by Ørsted, accidentally in the laboratory. When he discovered that current carrying conductor can produce magnetic field, we used in many parts. We made many devices, appliances where we use the magnetic effect of electric current. Many devices. But there was a scientist that time, his name was Michael Faraday. This Michael Faraday always believed that nature has symmetry. The same statement you will hear from one more scientist in physics. His name was, anybody knows? De Broglie, or somebody will call de Broglie, whatever. De Broglie was another scientist who believed in nature. He told nature has symmetry. And even Faraday, he believed that nature has symmetry. So he said that if current can produce magnetic field, why can't magnetic field produce current? Interesting thing. Today we know, so we are boldly saying. But that time, imagine 1800s, when there was no current in many parts of the world. America had, England had. What current they had? On DC current only they had. So wherever they want to light up, they will set up a battery factory. Some 4 or 5 cells they will set, anode, cathode, chemicals, electrolytes, and they will burn the powerhouse. Burn in the sense, lights, these things will be there, fans will be there. Very limited electrical appliances, but India at that time was only with fire. Not even a single place had current. So, it was very difficult to commercially make available DC. It was a difficulty that time. And who was ruling? Thomas Alva Edison. He was the founder of this. Founder means commercially he made it available to market. Batteries were found by many other scientists, Volta, this thing, that thing. People are there who have made this battery discovery. But the person to use this battery to make bulb, glowing bulb, and giving supply to many parts of the world, especially in US and England, Europe, was Thomas Alva Edison. Biggest problem in DC was we cannot transport it from one place to another. If I produce the current here, I must use the power in nearby area only. I cannot produce power here and send to Andhra Pradesh. Why Andhra Pradesh? Not even to Guduvancheri I cannot send from here by battery. Biggest disadvantage, biggest disadvantage. That time when the world was depending upon DC, DC means direct current. This scientist, Mr. Michael Faraday, he was thinking about what can I do to make current from magnetic field, because already Hans Christian Ørsted had found magnetic field from current. What he did series of experiments. Nothing much we will learn here, but if you read about that in some books of Michael Faraday, you will understand that he did thousands of experiments. After doing so many experiments, he found that magnetic field does not produce any current, but changing magnetic field produces current. And he named that current as induced current. Why induced current? Because current is not directly coming, it is getting induced. And then he gave 2 laws of electromagnetic induction, which we will learn today. But before I go into the interesting part of discovery of this AC and how he found that experiments by him, understand the first topic in this chapter is magnetic flux. Give the heading as magnetic flux, given by phi. I hope you remember what is electric flux from the chapter number 1. Electric flux was defined as number of electric field lines passing normally through an area. Same will be the definition here, write it down fast. Number of magnetic field lines, number of magnetic field lines, number of magnetic field lines passing normally through an area, number of magnetic field lines passing normally through an area is known as magnetic flux. Passing normally through an area is known as magnetic flux. Is known as magnetic flux. Okay. So what was the expression for electric flux? Phi is equal to EA cos theta. So what will be magnetic flux? BA cos theta. So you can write phi B is equal to BA cos theta. What was theta in the case of electric flux? Angle between electric field and area vector. Remember that. If you have an area like this, electric field is like this, don't think electric field is perpendicular to area. No. Electric field is parallel to area. Because if area is this, area vector is like this. And electric field and area vector are parallel to each other. Same way, if you have magnetic flux, what will be theta here? You can write B is magnetic field. B is magnetic field. What is A? Area of cross section, area I should say. Area. And theta is the angle made between magnetic field and area vector. Remember this. Because area vector is not same as area. Area vector is perpendicular drawn on an area. Remember this always. So if you see this as magnetic field and this as area vector, then here theta is how much? 0 degrees, not 90 degrees. If you remember electric field, SI unit of electric flux, we call it as Newton per Coulomb into meter square. So Newton Coulomb minus 1 meter square, or volt per meter into meter square, voltmeter. These were the SI units of electric flux. This question comes in the board exam. What is the SI unit of magnetic flux? So one thing can be Tesla meter square or Weber. Write it down. SI unit of magnetic flux. SI unit of magnetic flux is given by Tesla meter square, more famously called as Weber, W-E-B-E-R, or W-E-B also you can write. W-E-B-E-R or W-E-B also books will write, Weber. So Weber is the SI unit of magnetic flux, not of electric flux. I have seen students writing Weber as the SI unit of electric flux getting 0 mark. Don't write SI unit of electric flux as Weber. Only for magnetic flux is called as Weber. Okay. Now, if you have written all these things, next heading you give as Faraday's experiments. Faraday's experiments. Now please pay attention, I will give time for writing. I will give time for writing. Understand the experiments. Ivan, something you want to say?
So can you show a previous slide one more time, sir?
Yes. Shakti will let me know when I can proceed.
Sure, sir.
Shall I?
Okay, sir.
Thank you. Now please pay attention, and then I'll give time. This is not much to write, it is to understand what experiment Faraday conducted. Please understand this, later you can write. What he did, he had some magnetic field here. What is magnetic field? Into the plane. I hope by now you understand. Whenever I draw into, it means into the plane. And how you feel it, the magnetic field lines are going like this, inside the board, from you towards the board. That's how the magnetic field lines are. Okay. So what he did in this magnetic field, he kept a loop, wired loop, some wire in circular form. He kept like that. And then he started to change the magnetic field. So he started to changing magnetic field. And then he noticed that when he kept a galvanometer here, galvanometer was getting deflected. I hope you understand my point. So when you had a coil, a wire, there is no battery here, nothing is there, just a wire. Imagine a copper wire or aluminum wire. In that wire I am connecting a galvanometer, and then I am just changing the magnetic field, increasing, decreasing, whatever I want I can do. Magnetic field should change. Then he observed that galvanometer is showing some deflection, which indicates current is coming. Second experiment, he had some magnetic field same like this. And he had something like this, a rail. Rail means a platform where if I keep a conductor, conductor can slide right or left. So he moved it right, left. When he was moving this area was changing. Less area, move this side, more area, move this side, much more area, making it less area. So area was changing. And he kept a galvanometer here. He saw that it is deflecting. First experiment, magnetic field changed, current came inside. Second experiment, area changed, current came inside. Third experiment, he had the magnetic field, and in this magnetic field, he kept a coil, and this coil he turned. I hope you are understanding how the diagram is drawn. This coil was rotated kind of, it is turning. If this coil was turning, then once again he saw that current is getting induced. So I am writing here as changing orientation, changing orientation. See, these are the experiments I am writing at the last. Last means he did thousands of experiments, but out of all these experiments, he concluded that changing magnetic field, changing area and changing orientation is creating or inducing some current in the coil. Now, if you remember in the last page, I have told you magnetic field, area and orientation gives what? Flux. It means that whenever there is a changing flux, there will be an induced EMF. Why I am saying EMF? Here he saw the current because the loop was a closed loop. Imagine he would have kept loop like this. Now, and he keeps a galvanometer here. Do you think any current will come on this? No. Because it is a opened loop, not closed loop. Current can flow only in closed loop. No current will come. No current will come. But one thing I will tell you, if you try to check the voltage across it, no, that will be there. It means potential will come, but potential can become current only if the circuit is closed. I hope you know this. You have a battery, you have a potential, but battery current in wire only the current will come. If you buy a battery, it has EMF, but that EMF converts into current when you connect to a circuit, closed circuit. Same logic. Something you want to ask, Sharan Ram, please?
First of all, how is that magnetic field created?
Where?
All of the experiments,
Huh.
clear that there's a universe magnetic field.
Hmm.
Then how is the magnetic field created?
By using some electromagnets. Use an electromagnet, create a magnetic field. Suppose a magnetic field is created, then keep a coil in that. By using the electromagnetic, increase the current, decrease the current. You can control that, no, by rheostat. So you can control the amount of current flowing. You know very well, current changing will change the magnetic field also. We can produce changing magnetic field. Got my point? Yes. Anything you want to ask, Krishna? Please ask me.
Sir, in the first case you told that, sir, when you change magnetic field, there will be some EMF.
Yes.
Sir, how Faraday changes the magnetic field, sir?
Just now, Ishranram asked the same thing. I am saying the same thing, that he used electromagnets. Electromagnets are the current carrying conductors producing magnetic field. So if you know that current is changing, magnetic field will change. Whatever formula you learned in the previous chapter, B is equal to mu naught I by 2 pi r, B is equal to mu naught I by 2 r, B is equal to mu naught I a square by 2 into r square plus a square power 3 by 2. All the formula you have I involved in magnetic field, right, Krishna Raghavan? So whenever you produce more current, you give more current, you have more magnetic field. If you give less current, you have less magnetic field. So he used electromagnets and he kept on changing the current. If you ask me, sir, how he changed the current, he did it by using rheostats. I hope you know by now in your school laboratory, by rheostat we control resistance. Less resistance, more current, more resistance, less current. So when we change the current, the magnetic field will change. If magnetic field was changing, he was having induced current. Are you getting, Krishna? I hope you are getting my point. Yes. So I was saying, once again I am coming back to what I told now. Faraday found that changing magnetic field, changing area and changing orientation creates induced EMF. He concluded that magnetic field changing, flux will change. Area changing, flux will change. Theta changing, flux will change. So he put in a very simple format and said that whenever there is a change in magnetic flux, there will be an induced EMF. Simple. Instead of changing instead of saying that whenever there is a change in magnetic field, area, orientation, simple word he used. Whenever there is a change in magnetic flux, there will be an induced EMF. That makes the first law of electromagnetic induction. First you can write this diagram if you want to write something, and then you give the heading as Faraday's first law. If you are done with this diagram, next heading is Faraday's first law. Faraday's first law of electromagnetic induction. Faraday's first law of electromagnetic induction. If you are done with this, have you copied it? Make it fast, please. Very simple diagrams. Shall I give the statement of first law? Fast. Shall I give the statement? Please take it down. Statement goes like, whenever there is a change in magnetic flux, whenever there is a change in magnetic flux, there is an induced EMF. Whenever there is a change in magnetic flux, there is an induced EMF, which will last,
Can you repeat the sentence again, sir?
whenever there is a change in magnetic flux, there is an induced EMF. Whenever there is a change in magnetic flux, there is an induced EMF, which will last only till there is a change in magnetic flux, which will last only till there is a change in magnetic flux, which will last only till there is a change in magnetic flux. I hope you understand. Very simple statement. The statement says that if magnetic flux will change, induced EMF will come, and this induced EMF will come only till the point when the magnetic flux is changing. When the magnetic flux stops changing, no current. So, in this experiment, if he is changing the magnetic field, current is coming. If he stops changing the magnetic field, current stops. Here he is moving the lever, current is coming. Stops the lever, current stops. He is rotating the coil, current is coming. He stops rotating the coil, current will stop. Are you getting my point? So, induced EMF will last only till there is a change in magnetic flux. One more paragraph you can write, change the paragraph and write. If the coil is a closed loop, then there is also an induced current. If there is a closed loop, if the coil is a closed loop, there will also be an induced current. Because you know very well, EMF is equal to current times resistance. So, if you have EMF and if it is a closed coil, divide by resistance, you will get the current. Okay. This was Faraday's. Tell me, man. Devadarsh.
Why do they use induced in EMF and current?
Why do we use the word induced, you are saying? Yes, we use the word induced because this current is not always present. This current comes only when there is change in magnetic flux. Magnetic flux stops changing, current stops. So, it is not the normal current, it is the current which is induced because of changing magnetic flux. Magnetic flux stops changing, even the current stops. Are you getting a point? That is why it is induced current, not the normal current.
Yes, sir.
Okay. Yes. Now you write the next heading as Faraday's second law. Faraday's second law of electromagnetic induction. So, basically first law and second law are very similar. Difference is in first law he told theoretically, in second law he says mathematically. So, write the second law statement. The magnitude of induced EMF, is the rate of change of magnetic flux. The magnitude of induced EMF is the rate of change of magnetic flux. So, if I write here mathematically, this induced EMF is equal to d phi by dt. You know very well, You know very well that d phi by dt, that is phi is magnetic flux, so rate of change means d by dt. So d by dt of phi will give you EMF, induced EMF E. This is like epsilon naught kind of, not epsilon naught exactly, something like that we represent the EMF. If you are not comfortable in this, you can represent by the letter E also, like this, whatever you are comfortable with. EMF is equal to d by dt of phi. Is it clear? Okay, now let us take some question, shall we? Since we have learnt some topic, let us take a question, a very basic question. Very, very basic question. I think everybody can solve it because you are in 12th standard. They have given the value of phi. Phi b is given as 5t square plus 4t plus 1. Okay. They are asking find the induced EMF at t is equal to 1 second.
14.
This kind of question is just to motivate you. Okay. Don't
14, sir.
Yes, if somebody is not getting the answer, then water, your hand, put in nose and die. Okay, it is live also, sorry. Next question you take. This question you solve, then I will believe you are really good. Simple question you solved, no? Next question you solve. Shall I give the question? Shall I? Take the question, please. A conducting coil, I hope you know how you solved the previous question. We differentiated it, guys, d by dt of phi. So it will become d by dt of t, will become 10t plus 4, put t is equal to 1, 10 plus 4, which is equal to 14 volts because it is EMF. I hope you know this much. Yeah, a conducting coil is placed, with its plane perpendicular to uniform magnetic field of strength 0.5 Tesla. I will repeat, a conducting coil is placed with its plane perpendicular to uniform magnetic field of strength 0.5 Tesla. If suddenly the radius of coil starts shrinking, the radius of coil starts shrinking at 0.1 millimeter per second. The radius of coil starts shrinking at 0.1 millimeter per second. Find the EMF induced when the radius of coil was 5 centimeter. When the radius of coil was 5 centimeter. Radius of coil was 5 centimeter. I will repeat the question. A conducting coil is placed with its plane perpendicular to uniform magnetic field of strength 0.5 Tesla. If suddenly the radius of the coil starts shrinking at 0.1 millimeter per second, find the EMF induced when the radius of coil is 5 centimeter. Good question. Solve it. Yeah, we can appreciate you for solving this question. Try. Kavya, if you are able to hear me, can you please unmute yourself? Kavya, if you are able to hear me. You joined just now, right?
Yes, sir.
Why are you joining late?
Sir, I went to hospital, sir, so that.
Thank you. Please continue.
Sir, I'm still in hospital, so I can't on my video, sir.
Okay, there is no problem, but listen to the class at least, okay?
Okay, sir.
Okay. Don't take more than 2-3 minutes, make it fast, guys. What, Shweta? I think it should not be correct. This was fast, you told me. Actually, if it is good, then I appreciate, but I'll appreciate only after it is really correct. I'll check it. I'll solve on the board. Guys, keep on solving fast. – 0.4. Let me check. I don't know the answer. I'll solve it along with you.
Sir, is there any chance of 0?
0. I don't think it can be 0. Try your maximum, then I will solve at the end. Don't worry. – 0.2. Let me check. 0.25. Let me check. Let me solve it now.
Sir,
Yes.
5 into 10 power minus 6.
Yash Praveen says 5 into 10 power minus 6.
Sir.
Let me solve this for you people. What is the question, Yogit?
A conducting coil
Hmm.
placed
Hmm.
if its plane perpendicular to uniform magnetic field
Hmm.
of strength 0.5 Tesla.
One second. Let me draw the diagram. I am just keeping a coil which is kept perpendicular magnetic field, and I am writing the magnetic field value as
0.5 Tesla.
okay, fine. What else?
Suddenly the radius of the coil starts to shrink
Okay.
at 0.1 mm per second.
1 second. So the radius is shrinking means dr by dt, isn't it?
Yes, sir.
How much it is given?
0.1 mm
Okay. Then
Find the EMF induced when R was 5
Hmm.
centimeter.
this is the question, am I right? Basically, it is not only the question of electromagnetic induction, it is also the question of application of derivatives. If you have learnt it. If you have not learnt it, you will learn it soon. If you have learnt it and still not able to solve the question, shame on you. Okay. So now, what they have given, very practical question, very interesting question actually. Magnetic field is given, a coil is kept. They have said radius is shrinking. It means it is becoming smaller. If radius will shrink, area will shrink. If area will shrink, area will change. If area will change, flux will change. If flux will change, induced current will come. They are asking you to find induced EMF itself, leave current, induced EMF they are asking to find. We know very well, induced EMF formula is d phi by dt. Any problem in this? We also know that phi is equal to BA cos theta. Theta is how much here? 0. Don't say 90 degree. Not 90 degree.
Oh,
Plane perpendicular. Plane
yes,
perpendicular
yes,
means,
yes, sir.
yeah. This is area and these are making 0 degree. So cos 0. Okay. So now it will become d by dt of B into A. What is area of the coil? Pi r square, isn't it? B is constant, pi is constant, no problem in that. What will be d by dt of r square? 2r is correct if radius is a constant. It is variable. So it will become B into pi into 2r into dr by dt. Am I right? R is changing, no yaar? This thing is derivative. I hope you are understanding this. From where sound came? From TV. Okay. So EMF will become equal to, now put in the equation here, what is the B value given? 0.5. What is pi? 3.14. What is R at 5 centimeters? So 5 into 10 to the power minus 2. What is dr by dt? 0.1 millimeter, 10 to the power minus 3.
10 power
Minus
minus 5.
5.
10 power minus 5.
Overall you are saying, eh? Okay, okay.
0.1
Then
you can into 10 power minus 3 you can take as 10 power minus
5, eh? Minus 4 only, no man?
Sir, 0.1 mm, sir. 1 mm.
Sir, we can keep pi as it is instead of substituting.
I can keep what as it is?
Yes, sir, we can write the answer in terms of pi, no, sir.
Why, man? They will give marks for that, eh?
Okay.
You can keep if you want, I will not keep. Okay, 5 into 10 is 10. 10 and 0.1 will get cancelled, right? Then 0.5 of 3.14, half of that. I'll do like this. 3.4 half will be how much? 1.57. 1.57 into 10 to the power minus 5 volts. Simple. Wrong means wrong. Half, padi, 1/4, 1/3, not accepted. It is MCQ question. How much marks you will get? Yes, tell me, Mr. Krishna Raghavan.
Sir, I used the same application of derivatives, sir, but I consider area of sphere, sir, 4 pi r square. And,
4 pi r square. Once again, 4 pi r square.
yes, sir, I have considered the sphere, sir.
Why you get a sphere, man? Coil cannot be sphere, right? What is this, man? Since you want sphere, you will keep sphere. Somebody will keep cylinder and try. How will the answer come then? It is coil. Coil means circular coil. Are you getting my point, Krishna? Otherwise, you understood, no, how I solved. Sai Akhilesh, there in the class. Absent. Absent means absent mentally. Did you get the answer before? Did you get the answer before I solved, or you got it after I solved?
After you solved, sir.
Why? Where you went wrong?
I don't know where to start, sir.
Now you understood.
Yes, sir.
This question is coming. This question has come in competitive examination, but now it will not come in competitive examination. That's why I gave in school examination. Once upon a time, this question had a level of NEET or JEE, but today it is having a level of school. I don't think it is that tough question that it has to be asked in competitive examination. Simple question only. If any doubt is there, you can ask me. If you are thinking why d by dt of r square became 2r dr by dt, that you should understand that it is d by dt of r square, not d by dt of t square. If it is d by dt of t square, yes, as you are thinking, 2t will be the answer. But d by dt of r square, it will become 2r into dr by dt. If you ask me why we differentiated it, r is a constant, I will take it outside. R is not a constant, r is changing here. That is basics of derivation, differentiation. In this quantity, if somebody has doubt, why he took b outside, why he took outside, but why he not took r square outside? Magnetic field is constant, pi is constant, r is not a constant, how it will go outside? That's why I took pi and b outside and I wrote d by dt of r square. Now r square is a variable, we have to differentiate it. So r square will become 2r into dr by dt. If I teach you in more childish way, then I will write one more step for you. Please, those who are confusing, for them one more step. Into dr by dr. Now it became simple. How it became simple? See here, b into pi into d by dr of r square into dr by dt. I took this dr here, dt outside. Now what is d by dr of r square? 2r. What remains? Childish way, but some people requires this, no problem. I hope you understood now at least what I did. I multiplied with dr by dr, and this dr I kept here, dt I took it outside. So d by dr of r square became 2r and dr by dt is multiplied. If you have comfortability in that, that is the way you should solve it. Got it? Shall I go ahead? Give the next heading as Lenz law. Enough of questions too. Later you can solve in practice class. Now we go to Lenz law. And Lenz law is something that I have taught you already. But I will revise it once again because majority of you are taking leave when I am teaching. So if you see carefully, you will realize that Mr. Michael Faraday, he gave this electromagnetic induction laws without bothering about direction of induced current, right? We are understanding EMF is coming here, but whether the current will be clockwise or anti-clockwise, he never talked about that. Who? Faraday. The person who talked about that was Mr. Lenz. Write the statement please, all of you. As per the Lenz law, as per the Lenz law, as per the Lenz law, direction of induced EMF, direction of induced EMF, direction of induced EMF will always be in such a way, will always be in such a way that it opposes the cause of it. It opposes the cause of it. Direction of induced EMF will always be in such a way that it opposes the cause of it. To explain it to you, which I have already done in the past, once again I am doing it. Lenz law said that whenever this induced EMF is coming inside, it is coming in such a way that it is opposing who is creating it. For example, if you have a solenoid kind of coil and I am not having any battery here, so no magnetic field, okay? I am just having a galvanometer. I am not having any battery here. Don't imagine magnetic field will come around the solenoid, nothing. Solenoid will create magnetic field only if you have a battery here, right? No current is flowing now, just a solenoid. If I bring a magnet close to it, let me assume this is north pole and this is south pole. Now this magnet will have a magnetic field around it. Do you agree with me? This magnet will have a magnetic field around it. I hope everybody knows this, from north towards south. When this magnet is approaching the solenoid, then the magnetic field is increasing in the coil. Please understand this logic. This is the base of Lenz law. If I am having a magnet here, there is no magnetic field inside the coil. But when the magnet comes nearer, the magnetic field in the coil is increasing. Magnetic field is increasing, magnetic flux is increasing, because magnetic flux is BA cos theta. So, if magnetic field changes, magnetic flux changes. Magnetic flux is increasing. If magnetic flux is increasing, induced EMF will try to reduce it. If it wants to reduce the EMF, this should repel the magnet. To repel it, it must become a north pole. And you know, if you don't know now, you can know that if some end becomes a north pole, it has to have anti-clockwise direction current. If a side is becoming a south pole, it will have a clockwise direction current. So, if this magnet is trying to enter the solenoid or the coil, it will produce anti-clockwise direction current here. We will show in the galvanometer. And suppose this magnet goes inside the coil and stops here. No deflection in galvanometer, because magnetic field becomes constant, not changing now. Magnetic flux becomes constant, not changing now, and d by dt of constant is 0, no EMF. Induced EMF is d by dt of phi. Only phi is changing, it will have some value. If phi becomes constant, E will become 0. Am I right? Once again, if you try to take out the magnet from inside, now what will happen? Understand conceptually. When the magnet is trying to come out, the magnetic field is trying to reduce. So, when the magnetic field is trying to reduce, induced EMF will try to increase it. If it wants to increase it, it has to once again attract back the magnet. To attract the magnet back to itself, it must become a south pole. Then only it can attract it back. If it becomes a south pole, it must have a clockwise current. So, now that current direction will reverse. So, in this solenoid, when I try to make the magnet go inside it, I got an anti-clockwise direction deflection. When I try to make it bring it outside the solenoid, it will get a clockwise side deflection, indicating that direction of current is changing. This is what is Lenz law. As per Lenz law, you will put direction of induced current in such a way that it opposes the cause of its creation. One example I gave you. Like that, many examples I can give you. Another example I can give you is this example, which is there in NCERT book also. In example question, we have discussed about this in the 5th chapter class also. Suppose there is an into the plane magnetic field. Pay attention. Into the plane magnetic field. I am taking a coil here. This coil is moving towards the magnetic field. I am writing 4 positions of magnet. Position number 1, position number 2, position number 3 and position number 4. I hope you are understanding. Coil is moving this side. Okay? There is a coil moving from 1 and reaching till 4. When it is moving from 1 to 2, whether magnetic field is changing? Yes. Increasing or decreasing? Decreasing. Increasing. Because if it goes inside the magnetic field, more magnetic field is entering. Initially 0, then some value, then more value, maximum value. When the magnetic field will change, magnetic flux will change. Do you agree with me? If magnetic flux is changing, induced current will come. Induced current will come in such a way that it will oppose the cause of it. What is the cause here? Increase in magnetic field. Which magnetic field? Into the plane magnetic field. How can you decrease it? Creating out of the plane magnetic field. Into the plane magnetic field can be reduced by creating out of the plane magnetic field. If you want to create out of the plane magnetic field, you must have what direction current? Anti-clockwise. So you will have anti-clockwise current here. Now pay attention. When it is moving from 2 to 3, whether magnetic field is changing? No, obviously no. Same magnetic field. If magnetic field is not changing, magnetic flux will change? Magnetic flux will not change, induced current will come? No induced current in third. But when it starts going from 3 to 4, magnetic flux, magnetic field is changing? Yes, increasing or decreasing? Decreasing. If it is decreasing, induced EMF will try to increase it. Increase what? Into the plane. To increase into the plane, it also produce into the plane. What will be that? Clockwise. So when the coil tried to enter the magnetic field, it produced anti-clockwise current. When the coil exited the magnetic field, it produced clockwise current. But when the coil was inside the magnetic field, it produced no current because there was no change in magnetic flux. I hope you are understanding this. Any problem in this Lenz law? If anybody has, please ask me. You can write the example if you want to write. I mean, you can draw by yourself in your way. Today you are understanding, definitely in 1 week you will forget this. So I will give some steps to remember. When you study for the examination, you should remember it, right? So for that, let me give you some steps. Shall I give you some steps to you? First you write, if you want writing something, I will erase the board. I will go to the next page. Yes, please. There are some students from SSM school thinking that why we are learning EMI 6th chapter in my school, still they are in 1, 2, 3, 4 only. Guys, one day they are going to come to 6 also. Don't think that your school will get over in 1, 2, 3, 4 itself. And if I am ahead of your school, it is basically advantage for you. Remember that. When they teach in school, it should become easy for you. So don't think that why I am learning this. Be happy that you are learning it before the school is teaching. And for you to cope up in your school exams, I told you I am going to come on Fridays. Even coming Friday, I will come there, SSM Nagar. And remember, I will continue from where I left in the previous class. Capacitance I will start. All the students newly joined, Ananya, Amrita Varshini, especially who have missed the classes in beginning, are requested to see the video and be ready for that topic. Like last class, I will come and revise everything, but I will not give notes because I cannot give notes in that short duration. Something you were saying, somebody? Online class? I heard some sound coming in the middle. Anybody saying something? Okay. Shall I give the steps now then? Since I am sure you will forget it, write some steps. So step 1 is identify whether magnetic flux is changing or not. First step is this. What would be step 2 then? There are two possibilities. No, whether flux is changing. And second thing is, if flux is not changing. If flux is not changing, no problem, induced EMF will be 0. But if flux is changing, there are two possibilities. What possibility? Flux is increasing or flux is decreasing. Identify that, second step. Step 3. If flux is increasing, put direction of current to reduce it, and if the flux decreases, put direction of current to increase it. I will give some more examples to you before I jump to the next topic. Have you written this? Make it fast. If write it, you may think a simple thing only. Tomorrow you will forget, I am telling you. One announcement I am making. On this Friday, please pay attention, on this Friday at 9:30 p.m. that is the only time I am available, and you are also available mutually. At 9:30 p.m. I am going to take a class on alternating current. This is because of the demand of some students who are having AC in their upcoming examination. This class is just for the sake of students who want to learn AC now. If you miss also, there is no problem. It is not a compulsory class. It is an optional class for anybody who wants to learn AC early. It will be a live class. If you want to come, you can come here, but I will not recommend you because it is late night. 9:30 it will get over by 10:30 only. So you can attend it from your home in the same studio I will take. If you have AC in your upcoming school exams, I will repeat once again AC in this class in the same order. This class is not a compulsory class. It is just for the students who wish to learn AC before I teach here in the regular class. Okay, 9:30 p.m. on Friday for 1 hour up to 10:30 p.m. If you want, you can come, but it is not recommended to come here. Attend from your place, and it is not compulsory also. If you wish to learn, you can learn. So I am going to teach AC in that class. Okay, coming back. Shall I proceed further? Allow me. Everybody in the online, can I proceed further?
Yes, sir.
Okay, thank you. Next, let me give some examples to you based upon Lenz law itself, because many questions are there from Lenz law, especially in competitive examination. Many kind of questions can come. In school also it may come. One question, very simple, I have already asked in the 5th chapter also. Suppose I am having, listen and answer. Okay, I'll ask you, then you will answer, not randomly. I'll take your name, you can answer. So current is flowing in this wire. Okay, there is a coil kept on its right hand side. Why I am drawing current? Yes, coil is A, B, C, D. There is a current flowing in the wire. Towards the right of the wire, there is a coil, name is ABCD. My question is to Suraj, whether any induced current will be there in the coil or not. Think and say. Why?
There is no magnetic field.
Magnetic field will be there, but not changing magnetic field. So your answer is right, but explanation is wrong, because the moment you have a current, you have magnetic field around it, but constant magnetic field. Since the magnetic field is constant, magnetic flux will be constant. Magnetic flux is constant, the induced EMF will be 0. This is logic. Okay. Coming back, Karthikeya Balan, if the current is increasing, Now whether any induced current will come in this coil or not? Yes. Step by step you tell me which direction the current will come. A, B, C, D, A. Okay, fine. Why? How? Explain me step by step. Good. So how you are claiming that anti-clockwise current will reduce the magnetic field? Explain me step by step. Your answer may be right, but explain me. You should say that since the magnetic field here will be into the plane, am I right? Are you getting my into the plane? Because right hand thumb rule. Current is increasing, magnetic field is increasing. Which magnetic field? Into the plane magnetic field. Induced current will try to reduce it. For reducing into the plane magnetic field, it must produce out of the plane magnetic field. So out of the plane magnetic field will come in anti-clockwise direction. So your answer is correct. A, B, C, D, A. Got my point, Karthik Balan? Nobody will ask you this explanation. But if your logic is not good, no, you will miss somewhere else. I hope you get my point. Okay. Now my question is to Kirti. I hope you are there in the class.
Yes, sir.
Okay. The question is, now the current is constant. Current does not change. Okay. Current is constant. But the coil is moving and the coil is going in this direction. Now tell me whether induced current will be there or not. Yes or no? Not sure. Okay, I'll give another chance to you. So I'll ask Anshul, what about you? You want to try this question?
Not sure, sir. I guess it will not be there.
Okay, you say it will not be there. I'll come to you. I'll come to you. So Krishna Raghav, you want to try this question? Step by step you will try.
Sir,
Yeah.
so it's moving right now, sir.
Yes.
Sir, so it tries to increase the into the plane magnetic field, sir.
You tell me.
When it moves out,
Tell me step by step. When the coil is trying to move towards right, whether magnetic field is increasing or decreasing for the coil.
sir, when it moves away from it, it decreases, sir.
Very good. Why it decreases? Because magnetic field formula is mu naught I by 2 pi r. R is increasing, B will reduce, isn't it? So as you move away from the wire, the magnetic field is going to reduce, right, Krishna?
Yes, sir.
Okay. So magnetic field is reducing. So what will induced current do?
Sir, it is trying to increase the magnetic field into the plane, sir.
Very good. So what is the direction?
Clockwise, sir.
Clockwise. Clockwise means A, D, C, B, A, right?
Yes, sir.
Correct, you are right. Okay. Next question. Next question is to Pratap. Pratap, unmute yourself.
Yes, sir.
Now the question is, the same coil
Yes, sir.
is trying to move downwards. Listen, understand and then answer, Pratap, okay? Take your time and answer, but answer correctly. The coil is moving downwards. Whether induced current will be there or not, yes or no?
1 second, sir.
Yeah.
No, sir.
Why, Pratap?
So because the wire is uniformly charged, so that you have a uniform magnetic field. Magnetic field does not change and the distance does not change. Distance from the wire does not change.
Yes. You are correct.
And also angular area doesn't change, so that there will be no net magnetic flux and no EMI.
Magnetic flux will be there, but no changing magnetic flux.
Yes, sir.
Yes.
It's a uniform magnetic flux.
Yeah, so the thing is, when it moves down or it moves up, the distance of wire remains same. Am I right?
Yes, sir.
So this point and this point will always have same magnetic field. So even though it is moving, neither area is changing, nor magnetic field changing, nor orientation changing. It means magnetic flux not changing. If magnetic flux will not change, then there is no chance of induced EMF. I hope you are getting my point.
Sir, can I mute myself?
Yes, you can mute yourself.
Thank you, sir.
Kirti, unmute yourself. Video is also off. Okay, I not saw the chat, but you can answer me, right? Now you will try one question. Yeah, try. Right or wrong is secondary, okay? Now the current is decreasing in the coil. Whether any induced current will come in the coil or not, yes or no?
Yes, sir.
Oh.
Because there is a change.
Magnetic flux. Now tell me step by step, what is the direction of induced current in the coil and why? Step by step. Try. Sai Rakshana, be ready. Next question coming to you. Don't jump off the meeting. Yes. Kirti, please go ahead.
I'm not sure why it is.
You see, step by step, Kirti. Just now you are listening to the class, right? Last 3-4 examples which I gave, step by step. Identify whether the magnetic field is increasing or decreasing. If it is decreasing, try to increase it. If it is increasing, try to reduce it. That is the logic. Okay, I'll give one more chance to you later. Sai Rakshana, unmute yourself. Will you try? Can you try? Tell fast, don't waste the time. Very good. At least be in the class here. Listen what is happening. Anbarasi, you want to try? Give a try, right or wrong is secondary. Whether induced current will be there or not. Kirti told yes, it will be there. Do you agree with Kirti and Anbarasi?
Yes, sir.
Okay, now tell me whether it will be clockwise or anti-clockwise and why? Okay, then listen very carefully. Don't be absent-minded. It's very important topic we are learning now. Dishita, you want to try Dishita?
Yes, sir.
Please try.
As it decreases, we should increase the current in the coil.
Not current, magnetic field.
Magnetic field in the coil. So we should go with clockwise, sir.
Yes, you are right. So here magnetic field is reducing because current is reducing. The formula is in front of you. If the current will reduce, magnetic field also will reduce. So magnetic field is reducing, induced current will try to increase it. To increase it, it must increase the into the plane magnetic field. So the current must be clockwise direction. You are right, Dishita. Good. I hope something is going inside the head. It's very complicated topic until you don't understand. The moment you understand, nothing can be simpler than this. Something you are asking, Yogit? What? Very good. So if you have another conductor placed this side also, then it depends upon the net effect of both. Are you getting? If same, then it will have zero EMF. Are you getting? Depends. Current flowing which direction.
We can't change the,
Yes, Mithun, please go ahead.
sir, we can't change the position of the wire as
Change if you want to change. You want to move wire away from it, move it. If wire is moving, once again distance will change. Distance will change means definitely magnetic field will change. Magnetic field change means magnetic flux will change. Magnetic flux will change means induced current will be there. And you will put the induced current based upon whether it is increasing or decreasing the magnetic field. Are you getting my point?
yes, sir.
I hope. Another one is current direction. And what is the magnetic field? This current is increasing or decreasing? Then solve step by step again. You will find this effect, this effect. If they both are having same effect and same magnitude of current, same amount of decrease, they will cancel each other. If they are having different, it will add each other. Simple concept here. If it is producing clockwise, it is also producing clockwise, they will add up. It is producing clockwise, anti-clockwise, they will cancel each other. Simple logic. Okay? Loudly? Yeah, if i's are different, then once again it will have different value. And we have to calculate by net effect only. I hope you're understanding all this. Is it clear, guys? Whatever I have taught in last few minutes, is it clear to you? I can assure you, expect question to come in the board exam from here, school exam from here, our exam from here, NEET and JEE exam from here. Everywhere in the upcoming days, you will get questions from Lenz law. If you don't understand this, ask me, I will tell you. No other option is there in your hand. Next topic is methods of producing induced EMF or methods of generating induced EMF. Give the heading as, yeah, please tell me, Shaktivel.
Sir, Lenz law, can you like repeat it again, sir? Like just a like summary. Once more, sir. I'm not quite getting it fully.
Okay, I said in Lenz law is giving the direction of induced EMF, okay, and as per Lenz, direction of induced current will be in such a way that it will try to reduce, not reduce, it will try to oppose the cause of it. Now suppose there is a coil here, okay, this coil, if you are making a magnet to drop on this coil, drop means pass through it. If the magnet is having north pole here and south pole here, when the magnet is approaching the coil, then the magnetic field is increasing in the coil. Why I say that? Because this magnetic field lines initially not in contact, but as it comes near and near, it will come in more contact, right? My point is clear to you, Shaktivel?
Yes, sir.
So if the magnetic field is increasing, the induced current produced in this coil will try to reduce it, right? Why it will reduce it? Because the cause here is increase in magnetic field. So if it wants to reduce it, it must become a north pole. Then only it will repel the magnet to reduce it. And just now I told you, if it wants to become a north pole, it must have an anti-clockwise direction current. That's how the Lenz law works. Are you getting my point? If I ask the same question to you, that this magnet is trying to go away from the coil in this direction. Now the magnetic field is reducing. Induced current will try to increase it. So it will become south pole to attract it back. And south pole means clockwise current. So it will become clockwise. This is the logic, man, Shaktivel, in simple words if I say. If you still have problem, yeah, if some people still have problem in Lenz law, message me, contact me, I will separately teach you, but don't leave it. It's an important topic. And simple also. I am guaranteeing you, if you are understanding Lenz law now, whatever I have taught now is very simple for you. But if you are not understanding now, it will become very complicated for you in the future. Shall I proceed further? Next topic is methods of generating induced EMF. Methods of generating induced EMF. Methods of generating induced EMF. One thing I should have told you, wherever you wrote Lenz law, I will request you to write E is equal to minus d phi by dt. Minus indicating that it is opposing the cause of it. So Lenz law told E is equal to minus d phi by dt. In school exam, if they ask you define Lenz law, after defining you also write this mathematical expression, E is equal to minus d phi by dt, where minus is indicating that direction of induced current is opposing the cause of it. Okay, coming back. Drop your pens, pay attention, I will give time for writing. Please pay attention. So you know that flux is equal to B A cos theta, right? Just now I told before some time. You also know that theta is equal to omega t from your 11th standard itself. Those who don't know, I will tell once again. Omega is called as angular frequency or angular velocity. Angular velocity is angular displacement by time. Theta is equal to omega t. Omega is angular displacement or angular frequency, which is also given by omega is what? 2 pi nu or 2 pi by t. These things you should know by now. If you are not knowing, then you are weak in basics of 11th. Omega is 2 pi nu or 2 pi by t. So I can write theta is equal to omega t. Also, for n turns, see, one turn of coil, it is BA cos theta. For n turns, phi will become equal to n BA cos theta. I am writing as omega t. Do you agree with me? Do you agree with me? Now, if I ask you, what is induced EMF? You know very well, induced EMF is negative d by dt of phi, isn't it? By now, by learning Faraday's laws and Lenz law, you very well know that induced EMF is negative d phi by dt. Any problem in this? So, if you want to create induced EMF, the heading is methods of generating induced EMF. If you want to generate induced EMF, you have multiple options. Number of turn changing is like, irrespective. Why we want to think about number of turns changing? It is irrelevant. Rather, magnetic field can be changed, area can be changed. So, suppose you are changing the area of the coil, you will have induced EMF. If you change the magnetic field of the coil, you will have induced EMF. But think, imagine, changing the magnetic field, how we can do? Many ways are there. One way is see what I can do. I will have a coil here, and I am having a battery here, I am having a key here. I turn off, turn on, turn off, turn on, turn off, turn on. The current is changing. When I turn on, from 0 to maximum, current changed, magnetic field changed, magnetic flux changed, induced current will be coming. Turn off, current became 0, magnetic field became 0, flux changed. So, one way is off, on, off, on, off, on, off, on, off, on. That will change the magnetic field. Is it practical? You want to have some person offing, onning, offing, onning, offing, onning. Impractical. Same way, changing area. Is it practical? Yes, it will produce increasing the area coil, reducing the area of the coil, increasing area of the coil, reducing area of the coil. It will give you induced current. Something like MCG I told you. Definitely, if you increase the what was that sensitivity of galvanometer I told you, no, which was equal to Vs and Is was there. By that I told you, if you increase the magnetic field, increase the area, so these things are going to increase sensitivity, but impractical. Same way here also, changing the magnetic field, changing the area of the coil is definitely going to give you induced EMF, but it is impractical. You know what is the best solution? Changing the orientation, and that's what we do, and that is what we do. Whenever you want to create induced EMF, what we do, you know, we change the orientation of the coil. You know how we do that? If you have one magnet here, north pole, one magnet here, south pole, north to south we have magnetic field lines. If I am having a coil in my hand, okay, if I sit and keep on rotating, what will happen? Orientation is changing. If orientation keeps on changing, I will be having induced EMF. How it will come, that we will learn now. But first you write for this method is, first method you write changing magnetic field, changing magnetic field. Second method is changing area of the coil, and third method is what I am going to teach you in detail, which is changing the orientation of the coil. I hope you copied this. So, methods of generating induced EMF, there are three methods. One is changing the magnetic field, second is changing the area of the coil, third I wrote here as changing the orientation of coil. Same thing that I taught in the beginning of today's class, experiments of Faraday. I am doing that in detail now. So, please pay attention. I will give time for writing. Please pay attention, 2 minutes. So what I am going to do now, I am going to have magnet, and that I am going to keep a coil, and I am going to rotate the coil. But since I want to draw in one diagram, what I am going to do, I am going to just draw north pole here, south pole here, and in between I will draw all the orientations possible. Okay? Instead of doing diagrams multiple times, don't think that it is happening like that. In real life, one north, one south, in between only I am rotating. But I will draw all the orientations for you separately. So first orientation, north to south, means how the magnetic field lines are going from north towards south. I hope you realize this. I am going to keep coil in that. So first position of coil, difficult to draw in 2D, I am drawing a 3D diagram. It is like this, which is something like area is parallel. This is area vector, are you getting my point? And magnetic field in same direction. What is theta here? The magnetic field this side, area this side, how it will be 90? Theta is 0, theta means omega t is 0. So what was, okay, we will come to that later. This first is theta is equal to 0. Second, I am moving this, right? First position what I kept was like this. Now I am going to rotate like this. Please pay attention, guys. I gave 90-degree rotation, isn't it? From here 0, I am at 90 degree. So now I am drawing the coil second position, and now the coil, it is difficult to draw inside, but here theta became how much? 90 degree. Because this is the way, theta is going inside it. Then I am going to draw in this direction. Once again it came here. So theta became how 0 here? 0, 90, 180, no? Think full circle. Then once again it will become how much? 270. And once again it became 3 size group 360. Do you understand what I am doing? I will do it once again in front of you. This was north, this is south. So magnetic field and the area vector are parallel, 0 degree. Then I turned like this, see this where it came. Just see the area vector. This is the area vector, making 0 degree now with the magnetic field. It came down 90 degree. Then it went here. How much it made when it came here? 180. Then it came here, how much it made? 270. Then it came here, how much it made? 360 or 0 once again. Now it is waste to talk further. I got 0, 90, 180, 270, 360. Now we know that I am writing it here, please pay attention. E is equal to d by dt of phi. Phi is n b a cos omega t. I forgot to mention minus here. Minus here. Why minus here? Because Lenz law says that induced EMF will oppose the cause of it. So here I will get E is equal to minus n b a outside, everything is constant. What is d by dt of cos omega t? Minus omega into sin omega t, right? First cos omega t will become sin omega t, minus sin omega t, and omega t will become omega. I hope you understand this basic differentiation. Minus minus will become plus, so E will become equal to n b a omega sin omega t. Are you clear in this? Whatever I am telling now is the input of next chapter. If you fail to understand this, it will hit next chapter also. This part is the input of chapter number 7. So please be very careful about this topic. So E became equal to NBA omega sin omega t. Since it is NBA omega sin omega t, if I am putting the values here, or I can write like this also. If omega t is equal to 90 degrees, Then what will be sin omega t? 1, sin 90 is 1. So E will become maximum, so E will become E naught. E naught will become equal to N B A omega. E naught is called as peak EMF, maximum EMF. Maximum EMF possible is NBA omega only, because that is only 90 degree value of E. So if I put the value of E naught here, then I get E is equal to E naught sin omega t. This is called as equation of induced EMF. Equation of induced EMF. What is that? E is equal to E naught sin omega t. How it came? It came from here. This derivation I have done from here to here. It is the derivation of equation of induced EMF, which is E is equal to E naught sin omega t, where E naught is what? NBA omega. Now, put the values here of, please tell me, Pratap.
Sir, you have written like what is the direct name of E naught?
Peak EMF I have written.
Oh, okay, sir.
Peak EMF. Peak means maximum, maximum EMF. Okay?
Okay, sir.
Now, pay attention. So, here E will become equal to, what is the formula? E naught sin omega t. Here omega t is 0. E will also become 0. Here 90 degree, E will become E naught. 180 degree, E will become 0. 270, E will become minus E naught. 360 degree, once again E will become 0. I hope you know that sin 0 is 0, sin 90 is 1, sin 180 is 0, sin 270 is minus 1, and sin 360 is 0. Sin n pi is 0, 0, 1 pi, 2 pi, 3 pi, n pi, whatever you take, 0 only. Now, if I plot all these things on a graph, you will realize that 0, maximum, 0, minimum, 0. What graph came? Sine graph came. Obviously, sine graph only will come, sine equation is there. That is why this EMF has a name, alternating EMF, because it is changing after every half revolution. Alternating EMF is a sine wave equation. Why it came like that? Because you can see here it is changing 0, E naught, 0, minus E naught, 0. Are you feeling that? So it became a sine wave. So what we do, now you understood that if I have in your home also, if you have two big magnets, North Pole, South Pole, if you have a coil, allot one person who is having no work in your home, ask them to rotate like this, what will happen? Current will be produced. I am serious on this here, don't think I am joking. If you appoint somebody who will stand and their work will be to rotate the turbine, whatever you call it, then it will give output as current. Problem is, magnet also big you can buy. Person who rotates, 10 minutes it will be fun, 20 minutes it will be torture, 1 hour his hands will pain, in 2 hours he will jump from the building, he will think that it is better than doing this. No, I will hire person, I will give 1000 rupees daily salary, and I will say you come and run for 10 hours daily. For 1000 rupees you are giving daily to him, you can buy current from the market itself, electricity board itself, that will be cheaper, right? I don't think anybody is getting below 30,000 rupees per month. If you are getting, you can try this. So, who will do this rotation work? Many people can do. People means wind can do. So, what we have in wind power plant? We have blades, behind we have armature coil kept between two magnets. When the wind moves the blade of the turbine, along with blade moving, coil also moves. The coil moves, magnetic field is changing, magnetic flux is changing, magnetic flux is changing, induced EMF is produced. If dam is there, put water to go, water hits the blade of turbine, turbine rotates, armature rotates, armature rotates, magnetic field changes, magnetic flux changes, induced EMF comes. I'll go to nuclear before that thermal comes. In thermal we have coal. Coal burning, boiling the water. Water gets boiled. Water becomes steam. Steam goes through pipe, hits the blade. Blade rotates, armature rotates, magnetic flux changes, induced EMF is produced. Instead of using coal, if you are using uranium, plutonium, it becomes nuclear power plant. Same work. Boil the water, make water steam. Steam goes through tube. Steam will go and hit the blade. Blade rotates, armature rotates, current is produced. Except solar cell. Solar cell is DC. It's not like AC. So whatever power you are seeing around you, either coming from Neyveli thermal power plant or coming from Kudankulam nuclear power plant, very far from you, Kalpakam nearby you, Kalpakam nuclear power plant, or somebody stays in near Theni or Madurai and getting from Mullai Periyar Dam hydroelectric power plant. Everybody is having the same mechanism of producing current. What mechanism? Rotate the coil in the magnetic field. So when steam is rotating, water is rotating, or air is rotating, it is not going to cost us much compared to human being rotating. I hope you get my point. And that is how the alternating current is produced. Okay? If you have understood this, copy it fast. We are going to end the class now. Make it fast. Copy it. This diagram and this values. In this topic, we are yet to learn motional EMF, self and mutual inductance. Then this chapter will be done. Small chapter. Next class it will be done and we will start alternating current also. Copy it fast. As you copy, you can start leaving the meeting. But don't forget, on this Friday, I am going to come to SSM Nagar for the class. And second thing is, I am going to arrange a night class for you. 9:30 to 10:30 online live class, where those who are interested can learn alternating current. Okay? So you copy and you drop. Good night, take care. Yeah, Devadarshan, tell me, Tambi.
Sir, when you will conduct the test, sir?
Conduct a test.
Class, sir.
Which class? SSM Nagar class? Online class?
Online test, sir, for alternating current.
For alternating current, I will keep on Friday at 9:30 p.m. Don't sleep on that day. Shivaratri.
Yes, sir.
9:30 to 10:30. Okay?
Yes, sir. Thank you.
Tell me, Pratap, I am hearing.
Yeah, sir, the assignment column for yesterday's worksheet, can you give time until tomorrow?
Yeah, I will give time till tomorrow only. Till tomorrow night it will be given. Okay?
Thank you, sir.
Okay.